And now we've got a few questions on rivers.
So here we are then, we can tell it's Christmas, we've got another figure. It says, using figure 15, give one piece of evidence that this part of the river is in its lower course. So we've got the river here, and you've got to say what makes you know that it's the lower course of the river. And here's 4 possible things you could say. So you could say it doesn't cross many contours, so has a gentle gradient. So the contours are the thin brown lines on the map which show a change in height of about 10 metres usually. And because there aren't many of those where the river is, you know that fairly flat land, which suggests it's the lower course. You could also say that the river's actually quite wide. So on here it looks pretty wide really, and therefore it suggests that it's also in the lower course of the river. Similarly, you could say that there's flat land surrounding the river, similarly because we can't see many contours around here, and flat land is usually found in the lower course of the river. And also you can see some meanders, so the river is like twisting and turning as it flows, and meanders tend to be found in the middle or lower course of the river. So any one of those would get you the map. Next question says, which grid square contains the tributary of the river with the steepest gradient? And you've got 4 options. So we've got, if you find those 4 options, you just want to find the one that's got the most contour lines in it, which suggests that it's really steep. And the one that does is 0976. If you look at 0976, so that point there, so it's this square, there's lots of contour lines here, which suggest that it is quite steep. So the change in height is quite rapid, so it's quite a steep square. Whereas if you look at the other 2, it's not quite the same as that. And 4.3 says, suggest the type of landform that may form in the future at 108794. And that's actually an Oxbow Lake, and I'll show you why. So at 108794, 108794 is about here. So we're looking about here. So at the moment it's a meander, and hopefully we know that a meander could eventually turn into an Oxbow Lake, because we're looking at what might form in the future. And you might have a meander, and just really briefly, the neck of the meander might get narrower due to erosion. You get erosion on the outside of the bend, deposition on the inside, and this might eventually cut through the neck of the meander, leaving an Oxbow Lake with some deposition here to block off the 2 ends. So an Oxbow Lake is the answer to that one. Now here we are with another figure, and it's 4.4. So study figure 16, a hydrograph for a river over a 3-day period. What was the lag time between peak rainfall and peak discharge? Now peak rainfall is the top of the bars here, it's where the peak rainfall was, and the peak discharge is the top of this graph where it shows you the discharge. So we're looking for the time between there and there, and if you work it out, it's actually 36 hours, so that's your answer. And for 4.4 says, suggest one way that cutting down trees near the river in figure 16 may affect the hydrograph. Now, as I've put here, if you cut down the trees, there'll be less interception, so less rainfall will be caught by the trees as it falls. So therefore there'll be more water running along the surface, which will get to the river quicker. So that lag time here will actually be a bit shorter, and the peak discharge might move a bit further this way. You could have also put that the peak discharge might actually be higher, because more water might eventually reach the river rather than landing on the trees and then evaporating straight off them. So the peak discharge could even be higher if you cut down a lot more trees. Hello, nearly there. So study figure 17, photograph which shows part of the river in North Yorkshire. I'm not going to try and pronounce that either. It says, explain how a combination of erosional and depositional processes have led to the formation of the landform shown. Now hopefully you know that this is a meander, so it's a bend in the river, and we need to try and explain how this is actually being formed in terms of erosion and deposition. So I'm going to show you this slide here. So this is showing you a cross section of that meander, so it's a cross section of pretty much what we've got here. Now on the inside bend of a meander, the water's a bit shallower and it moves quite slowly. So that's what we've got here. So we've got shallow water moving quite slowly, and that means that the water on the inside bend, because it's going slowly, it's not got as much energy, it can't erode, so deposition is the process that occurs. So we've got lots of sediment which has been deposited here, and that forms a gentle slope called a slip-off slope, which is what you've got here. However, on the outside bend of a meander, the water's flowing faster because it's deeper and therefore there's less friction. And this creates a river cliff here because the fastest flow of water leads to erosion in terms of hydraulic action and abrasion. The abrasion might even undercut the bank, which might cause it to collapse, and therefore that's why it's a lot deeper and there's a really steep side, making the river cliff. And that's what leads to this landform shown here. Last one. So last question on the paper, and it'd be rude not to have another figure. So study figure 18, a map of the Eden Basin in the northwest of England. It says, using figure 18 and your own knowledge, explain how physical and human factors may affect flood risk in the Eden Basin. It gives you a few important things in the key here which should definitely benefit you. So we need to say what we think makes the Eden River susceptible to flooding. Now, a couple of ideas are, if you look on here, it shows you that some of the tributaries of the river are actually flowing over impermeable rocks, which means rocks that won't allow water to sink into them. And that means that there's going to be quick runoff. So the water won't sink into the rock, it'll flow along the top and reach the river quickly, potentially leading to flooding. So that's what we're talking about in terms of geology, the rock type. Second thing is, if you notice on here, it says upland areas are shown by this sort of pattern. So lots of the tributaries are shown that are in upland areas, which means the relief is going to be quite steep. So steep-sided slopes, which means fast runoff to the river, and therefore that could also contribute to the river flooding. So there's two physical factors which might affect flood risk. Now, in order to get good marks in this question, we need to have human and physical. So human we need. One thing you might notice is that we've got some urban areas close to the River Eden. And in urban areas, tend to have buildings and roads which are impermeable surfaces, like concrete. So therefore, when it rains, the water will land on this concrete and flow along to the river rather than being soaked deep underground and infiltrating into the soil. So that's one factor that will affect flood risk. You might also have a lack of vegetation in urban areas, which means there's not going to be much interception in terms of trees collecting water as it falls from the sky. So therefore more water might reach the river, or it'll at least reach the river quicker. And these are a few more ideas you might want to note down.
And when you've done green pen on all of that, well done.